So here we'll discuss how to create NumPy arrays. So first we need to import this library called as NumPy, right? Import NumPy, and we will give the alias name or smaller name to this NumPy, which is NP, right? Import NumPy as NP. This NP is just another name of this NumPy. Whenever we are referring to this NumPy in this program, we are referring as NP, right? NumPy is called as NP. This is just renaming. So, so we are in Jupyter Notebook, by the way. So this is this software which I installed is Anaconda. In Anaconda, we have this Jupyter Notebook. Right? So import NumPy as NP. So now let's the first way to create this NumPy array is by using the list np dot a is the name of the array here, which is equal to np dot array. We'll call the array function on this np, array function of this np, and to this array we'll pass the list 1, 2, 3, and 4, right? And just execute. So in the print a, this is an array a. This is an array a. Now if you call a.ndim, you will get 1. It's one dimensional array. A.shape, you will get 4 comma. There are 4 elements inside this array a. 4 elements inside this array a. This is the first way to create an array. Now the second way to create an array is by using arrange function. A b is equal to np dot arrange. Arrange. There is a function in Python called as range. From that range, we have this arrange in numpy. So np is numpy. Np is numpy. Np dot arrange to this will pass the starting point, the ending point, and the step size. The third element here is the step size. Let's say I want to take the step size of 10. This starting point here, I want to start. I want to go till 100. 100 is exclusive. That means it will not be included. It will be excluded. And I want to take a step size of 10. 10. That means what I'm saying here is we are starting at 10, taking the step size of 10. That means after 10 we'll take 20. Taking a step size of 10, we'll go to 30, 40, 50, 60, 70, 80, 90, and we'll not take 100 because 100 is exclusive. 100 is exclusive. That means we will not include 100, right? So this array will get by using this. To this arrange function, we pass the starting point, the end, a stopping point, and the step size, right? Okay, so let's see whether we get this or not. And if we print b, okay, this is the array which we'll get, right? Again this is 1D array, right? If we call b dot ndim, you will get 1, and if you call b dot shape now, you will get 9 comma. There are 9 elements here, right? The shape is 9. This array contains 9 elements. If you call b dot size 9, right? So size is also 9. That means the size of this array is 9 elements. Okay, so now let's see one more method. C is equal to np dot random dot randint. We want to create an array of random integers, right? So in np we have random module. On that random we are calling this randint function to generate random integers. So again here I should mention the starting point, the ending point, sorry, and how many elements I want. Between 10 to 100 I want, let's say, 10 random numbers, right? So this is the starting point, this is the ending point, and how many random elements I want. So 10 random elements or 10 random numbers I want, right? You see these numbers are generated randomly. These numbers are generated randomly. So this, in randint, we are passing the starting, the ending, and the number of random elements you want. You will get 10 random integers here. One, if you call c dot size, right? Size is the property, so it will return the size of this array. This is 10. Okay, now again, let's say d is equal to, I have np dot random dot rand. Let's say I say 10, right? So if you see, this is an array. This is an array np dot random dot rand. It is returning us random numbers between 0 and 1. This rand is returning us random numbers between 0 and 1. Rand int was returning us random number in the specified interval. The rand int was returning us integers, right? So rand int was returning us integers. If you see at this, look at this, these are integers. So for rand int, we are passing the starting, ending, and the number of random integers we want. To this rand function, we are passing just the size, how many elements, random numbers you want. These random numbers are generated between 0 and 1. If you see, all of them are between 0 and 1, right? Similarly, if you want, there is one more function called as randn. D is equal to np dot random dot randn. If I say 10 here again, and if I print this array d, you will get these numbers, right? So these numbers are normally distributed number. This random function returns us number which are normally distributed, n for normal, right? Normal distribution, this kind of curve will get is a normal distribution curve, right? So these are equally spaced numbers from positive as well as negative side, right? Okay, so randint returns us the numbers which are normally distributed numbers. These numbers, if you look at, they are normally distributed numbers, right? Okay, so we saw here uh, 3-4 ways to create the. Let me show you. First, we created this array by passing the list to array. Then second, we used arrange function. Third, we used randint. Then rand generates the random number between 0 and 1. Randn generates the random numbers which are normally distributed, right? These are normally distributed random numbers. Okay, now we have this. We have, let's say, this array B, which is this one, or let's say array C, which is this one. What is the shape of size of this array? C dot size. Size is 10. There are 10 elements. Now let's say I want to convert this array into 2 dimensions, right? I want to convert this array, sorry, convert this array into 2 dimensions. How can I do that? Right, I can call the property resize, reshape. I can call a function called as reshape on this array C, and to this reshape I'll pass the size, right? The size of this array is 10, right? So I can convert into 2D array, 3D array, whatever, right? Let's say I want to convert it into 2D array whose size where there are 2 rows and 5 columns. So I'll pass reshape 2, 5. Remember, this 2, 5 or 2 into 5 must be equal to size of this. 2 into 5 must be equal to 10, right? So this is what I get, right? Now if we look at the original array, which is C, this C array is unchanged, right? we called reshape on C that returned this 2D array, but C is unchanged, right? Now, if you want to store this, we can store this in, let's say, some array called as E, right? E is equal to C dot reshape, and if we print E here, we'll get this array. Now, this array written by reshape, we have stored it in a variable called as E. Now, what is the size of this? What is the shape of this array E? E dot shape. It's 2 comma 5. There are two elements in the outer array. This outer array, if you look at this outer array, if you look at, there are two elements: the first element and the second element, right? And inside, that's why this 2. And how many elements inside this in the inner array? There are 5 elements: 1, 2, 3, 4, and 5. That's why the shape is 2 comma 5. Okay. Now let's see another array. Let's say I have an array, let's say A again, which is generated by using random numbers, np dot random dot rand int, again between 10 to 100. And now let's say I want to generate 20 random numbers. 20. So if I print A, if I print A will look like this, right? Now I want to convert this A into an array of, or I want to convert this A into the 3-dimensional array, right? The size of A is 20. A dot size is 20. It's 20, right? So how can I convert? How can I, let's say B is equal to A dot reshape. Let's say I want to have it as 2 comma 5 comma 2, 2 comma 2 comma 2 comma 5 comma 2. That means I will have the outer array containing 2 elements. There are 5 2-dimensional elements and there are 2 1-dimensional elements inside the 2D. The 3D contains 2 elements which are 2D. The 2D contains 5 elements which are 1D. The 1D contains 2 elements each, right? Okay, so let's see B now. How does B look? B looks like this, right? We see here the outer array, that is this array. This is the outer array, which is the 3D. This is the outer array, which is the 3D, right? So it contains 2D, two 2D arrays, two 2D arrays. That's why this 2, right? So this is the first 2D array and this is the second 2D array, right? Inside 2D, how many 1D elements are there? 1, 2, 3, 4, and 5. So that's why this 5. And inside each of those 1D, which are inside 2D, right? How many elements are there? 2, 1 and 2. Each 2D array contains, each 1D array contains 2 elements. That's why this 2, right? That's why that's why the shape of this is 2 comma 5 comma 2. So let's say if I write A dot shape, you will get 20. A dot shape is 20. A dot shape is 20, right? But if you write B dot shape, you will get 2 comma 5 comma 2, right? So that's how you can find the shape of the array. You can convert 2D 1D array into 2D or 3D array, right? In the next video, we'll see the slicing of these arrays.